All right, guys, so the first thing we should do is create the formula sheet you can have tomorrow. So just remind you guys, don't cross things out on your formula sheet. Don't rip the page of the formula sheet, because I don't know when that happened. So make sure you can bring the formula sheet in. We've had one before, right? Didn't we? So you can bring that one in, you can bring this one in, you can bring in tons of formula sheets, and they can be huge as long as you don't bother people near you, and as long as they only have what I said they can have on them.
So should I take the formula sheet and test correction?
Yeah, if you want to. As far as, yeah.
But I have to turn it back.
No. I already looked at it. I don't need it again. Okay. So this one starts at chapter 4. And chapter 4's got all that X, P of X stuff, right? So we're going to definitely have this little dude.
Can we label it chapter 4? Is that okay? 4 is fine.
Yeah, that's fine. I love you guys. Yeah, Jeff. Yeah. We know how to set up the class, Jeff. That's fun. Okay, so hopefully that looks vaguely familiar. How do you know when to use these? When they give you X and P of X, right? Doesn't that formula's got X and P of X in it? Probably use them when they give you X and P of X. Some people are trying to force the NP in the XP of X, but I'm like, that's never going to work. Let me see. That's it for that one. And then we got binomial stuff. Remember this little dude? This is chapter 4 stuff. 401, 42, 43.
Yeah. This is chapter 4.
Chapter 5, I told you there's a mean and a standard deviation for uniform, and I don't need you to write them down. I'm not going to ask you questions about them. I know I did on the practice test, and I don't care. It's a practice test. I can ask you what I want you to ask. Don't even write the formulas down for the mean and standard deviation, because I'm not going to ask. So chapter 5, there's no formulas. You've got to know how to deal with a uniform distribution. No formulas to write down for it. Everybody with me? Okay? Some guys are like, I don't trust you. Oh. Too damn
That's the one
bad.
with the square.
I am your only teacher. Huh?
That's the one with the square.
Oh, yeah. The square root of, you might say square root over 12. That's the standard deviation of a uniform distribution. I don't care about it. It's just, no? Okay, that's chapter 5. So the next thing we got is chapter 6. You can write this down again. Right, let me make that easier. You can write this down. Chapter 6. Then you got, that's the basics there, right? Then you got chapter 7, which introduces this. And I also, you don't necessarily have to write this down, it's going to become big later. It doesn't matter if I have a population standard deviation for individuals or a sample standard deviation for individuals. They both change for groups. This is chapter 7. Chapter 7 was that central limit theorem, dude, right?
What's the S right there?
What's the S? Standard deviation of a sample, because it's not a Greek letter.
Are we allowed to put X equals U plus?
Oh, yeah, good. I'm open to suggestions, because I know all this shit, but it doesn't mean I remember it. So remind me. Anything else you think we should have on the formula sheet? I'm open to suggestions. I will shoot most of them down. No? Does that look okay? Nobody wants to say anything else? Normally I got my smart asses saying everything, but okay. All right, that's it. So you're going to have this in any previous formula sheet you have that was not
I just
lost points on.
added it.
Yeah, you can just add these to your formula sheet, or you can put these on a different formula sheet and bring them both in with you, whatever you want to do. Or you can only bring this one because the probability stuff is not going to be on here. Right? It doesn't matter.
For the final, you just
For the final, just bring all your formula sheets. Yeah.
it's okay.
So for that bottom Z-score, that's just a change of standard deviation. That's that
This one is the change of z-score into a raw score. Which one are we talking
No, I'm
about?
saying the bottom Z,
These are the same formula, right?
but the S is with the sample.
Totally, but they're both just spreads. Yeah. Z-score is always my score minus the middle divided by the spread. It's always that. Always. So there's population, there's sample. Z-score doesn't give a shit. It's the same thing. Uh-oh.
It's because when I pour it out, it's fine.
All right.
I can rewrite it.
All right, let me give you this, the answer key, and then we'll see what you guys want to focus on for review.
No, I can't math the American. I have American.
You know your history, you know that
Well, I know that
America
this.
stole almost everything we use from everybody else. You know our number system is Hindu-Arabic number system, right? There's no American numerals. There's a Hindu-Arabic numerals for you. So, I don't know if you want to go down that road.
It's just sad that we can't make our own stuff.
Of course we can, but what the shit? We're not.
Sorry.
I know. I don't want to talk politically.
Number 4B, on your key it says 302, but ours is 315.
Oh, yeah, shoot. All right, so full disclosure, I kind of Frankenstein this key together this morning. I was so happy I actually found the key. So yeah, 4B, it'll be a little different for you. Because at some point in history I changed it, and this is the copy where I didn't. So 4B, you have to... All right, look at 4A. When you calculate that 4A on the practice test, you get the percentage, the score above a 302. So if I said there's 2,000 students for 4B, how many would you expect to score above 302? That would be that percentage times 2,000, because that's the percentage I expect. I ask you greater than 315, because it used to actually be 315 up there, to be honest. So you just have to calculate the probability that it's greater than 315. So well, let's do that problem together. So we got these here.
Mine says 302. Yeah.
That's what we're talking about. That's what we're
No,
talking
they're
about.
talking about why
Yes,
it's different.
yes, that's why we're going to do it now, because my key says something different. All right. So let's look at 4B. If I knew the probability that somebody scored greater than 315, like for example, let me ask you this. If I knew that 20% scored greater than 315, and I got 2,000 students, how many of those would I expect to score greater than 315? 20% of 2,000. Bam! Do I know what percentage scored greater than 315? No. Let me calculate that first. So why don't I change the standard deviation on 4B? What were the two things that had to happen to tell me to change the standard deviation? I take a Sample, and I ask about the sample mean. Am I asking about the sample mean? No, I'm not. So you don't change the standard deviation. It's just I got to figure out what percentage of 2,000 I'm going to take. So I got to figure out what percentage scored greater than 315. So what goes in the middle? 281.2. I want greater than 315. So it's the same thing we were doing earlier. You make a z-score. You look that z-score up. You get the area below. You do 1 minus. From my memory, I think it's, well, what did I say down here? Oh, that's right. They're both 302. It used to be both 315. I think it's 0.1611. That's close. All right. So 1635. Is that anybody else try that problem out? Let's do this together. So the z-score would be 315 minus 281.2 divided by 34.48. Right? Is that cool?
Yes.
And so if we do that, shit, there it is. We should get 0.98.
Yes.
And then if you look up 0.98 in the chart, 8365. So then it sounds like you're right. That'll be 0.1635. I like it. So then for, now there's 2,000 kids, I expect 16.35%. So then I just take 16.35% of 2,000. Bless you. 327, yep. So I would expect 327 to score more than 315. Then now watch. If there were 2,000 students applying to my school, applying to the school, and I required them to have above 315 on this test, how many students can I expect to make it into my school? About 327. You see how that's for planning purposes? Possibly, right? I would do something very similar because at the school I worked at on the East Coast, I was the math placement director. I placed every freshman into the first math course. Thankfully, we only had like 1,600 students at the school. Not 20,000 like we have here, but based on their information from high school, I would predict what their placement would be using something similar to this and figure out, we need more of these sections, we need less of these sections, so we can plan ahead for the semester. So this type of analysis is good for planning. Right? Okay, maybe. Okay, so that's that one. And I think there was one, I think the last one, for some reason on 6E, I just got tired. And it just stopped. But look at number 6 real quick while I'm talking about it. Part A, B, and C are very straightforward. Part D is the one using the mean and standard deviation formula from that section. I'm not going to ask a question like this on the test. So what did you put in the practice there? I don't give a shit. This is studying ideas. So, stay with me now. Chapter 7 does not care what the distribution looks like to begin with. Chapter 7 says whatever the standard deviation was, it's going to change. Right? So for D, I find the mean and the standard deviation for that distribution, for individuals. Then for E, I say we take a sample of size 43. So I got to change that standard deviation. You guys all looking at number 6? If you want to, pass. So I take the 1.732 that I got, divided by the square root of 43 like we always do, right? Because what tells me to do that? Because I took a sample and I'm asking about the sample mean. So I don't care. So the whole thing about 7 is it doesn't give a shit where the standard deviation came from over here. It's if I take a sample of whatever size, the standard deviation is going to change, divided by the square root of n. So that's the point I'm trying to make on this problem.
So So it's going to be like a normal problem where you give us a standard deviation since you're not going to find it.
Yes. Yes. Okay. Where'd it go? So here we got the new standard deviation is 0.264. So what's the probability? The other thing to realize here is, what did I do in 6b? Do you see how that's almost the same question, you guys? What distribution rules 6b? It's 6b. What kind of distribution is it? Uniform. So I have a way to do it there. Is it uniform still? What happens when I take a sample of size 43? It becomes... You do it, guys. It doesn't give a shit what it starts off looking like. If I take a sample above 30, it becomes...
Or normal.
Normal enough. So for part E, I took a sample, didn't I? Was it above 30? Oh shit, yeah. So what kind of distribution am I working with now? Normal distribution. So can I do it the same way I did part 6b? No, because that was when it was uniform. Now, the means are normal. So the whole point of this problem was not to make you feel like the mean and standard deviation formula for uniform was important. No. It was a beautiful example of here we got mean and standard deviation. I take a sample bigger than 30. That changes everything. Asking about sample means, now I've got to use a normal distribution. And I know it's normal because it's bigger than 30. Standard deviation's got to change. Oh, hold on. Let's finish this. So now I've got, what goes in the middle? What was the mean? 5. Right?
Yes.
From 2 to 8, so 5's in the middle. And I want to know from 4,4 to 4,7. So to figure out this area, I just do what with these? Do what? Do what?
You have to find
I gotta crawl under somewhere.
the areas that
Gotta find the areas. Before I can do that, I gotta make these into z-scores. I gotta make these into z-scores. Whatever those come out to be. I'm doing this problem because it's not done on the answer key. Jeff was just over it, I guess. Past Jeff was like, here it is. So I get negative 2.27 here. And I get negative 1.14 here. So negative 2.27, negative 1.14. I just got to look those up, get the area, subtract them. I like it. Hey, Mikey. So negative 227 comes out to be 0.0116. So very few, little below that. That makes sense. Let's weigh the shit down. There should be very little below it. 114 comes out to be 1271. And then you just subtract those to get the area in the middle. So was uniform. Why did it become normal? Why am I using z-scores now? Took a sample. Ask about the sample mean. Sample's bigger than 30. It's now normal. Sorry, yeah.
The standard deviation formula for 6D, we have that on our formula sheet.
Sure. I am not going to ask you any question that requires you to use it, though.
Oh.
Okay. So I wouldn't have it on there.
Okay.
That just freaked me the shit out. So I know, I love it. Students are like, why did you assign homework with it? Because the test is not the end-all, be-all of what you learn from a class. If you understand that, you're a little better off in college. I can't test you in every single thing, right? Homework is important for that reason, to be honest. If you do great on the test, but you don't do any homework, you actually missed out on some stuff. So you didn't get a complete experience. So that's silly. You guys kind of with me here? All right, sorry, I talked over something.
I was just.
Real quick, what's this? I'm sorry, let's finish this out. 1, 1, 5. 5?
Yeah.
Okay. Good.
I was just gonna ask him about 3 and 6.
So he's trying to pay me off. That's huge for me.
That was
Oh. That actually would boost my bank account a lot.
I was just wondering how you got it.
Which one?
On 6 week, how you got 3.
Oh, I didn't get 3.
It's not 3?
I got 0.3.
Oh, that's a point.
Yeah. Copying that thing, lost the point. Yeah.
I just have
That's another reason we put a 0 in front. I should have put a 0 in front.
that answers it.
Yeah.
On number 3, like the second part of 3, what does that mean, find the z-score bounding the middle 91?
Yeah, I love it. What z-score is bound in the middle 95%, roughly?
Two standard deviations.
-2 to 2. So I'm asking you the middle 91%. So how the hell do you do that? Well, the really first good thing is to draw the picture.
Got it.
The chart only understands areas below a z-score I'm trying to find.
Find it at 4.5, 4.5%.
Beautiful. If there's 91% in the middle, holy shit, I had a little puberty there. If there's 91% in the middle, what percent? So this is what I'm looking for here. I'm looking for those z-scores. How would I find this z-score here? I need to know the area below it. So if there's 91% in here, how much is outside?
4.5.
9%. So how much is on that side? 4.5 because of symmetry. That's why I got to say bounding the middle, so I can use symmetry. So this will be 0.045. Look it up, get the z-score. Yeah, whatever. So, I think it's 170. Yeah. If you look at the key, that's basically the exact picture I have. So if I said the middle, 84%, what are you going to look up? Yeah, 0.08. If there's 84 in, there's 16 out, there's 8% on that side, you look at 0.08. And why do I only have to look at that one z-score? If that's negative 1.7, that's got to be symmetry. Look at the word. It's symmetry. Look at it. Sure.
Yes.
All right. This is kind of dependent on you, whatever you want to focus on. If you want to focus on sleeping, you can leave and go sleep. Yes?
1A concept-wise, I had a question.
Well, real quick, we don't really show you guys. Watch this, guys. Or don't, but shut up. If I have a distribution that's like this, do the probabilities add to 1? Try it again. Do the probabilities add to 1? Yeah, they do. All day long. But why is it invalid? Well, because there's probabilities that are outside of 0 to 1. That's why you have to say both. I can make the freaking probabilities add to 1 all day long and have all kinds of freaky ass probabilities in the middle. So not only do they have to add to 1, they also have to all be between 0 and 1, and that's why you state both, because this could happen. If you only say the one thing, then that's all that matters. This is great. Go for it. What does this mean? Less than impossible. Holy shit. They haven't made that Tom Cruise movie yet. Tom, this is less than impossible. This is negative probability. I can do it. I can hang off an airplane. Listen, Simon Pegg will come with me. It'll be all right.
None of the double quiz is going to be on that test, right?
No, yeah. None of the probability stuff will be on this, the chapter 3. That's not on this test. It's laid out on the homework. It's 4, 5, 6, 7. That's all. Just 4 chapters. 2 of them are only 2 sections, so I don't want to hear any griping. Shut.
What's the next test?
I don't know. It's on the homework sheet. That's why I wrote them all down, because so I don't have to have them in my head.
Can I show you something?
Yeah.
So that,
Sorry.
0.045 in the top, that would be this week.
Yeah, that's 5 away, and that's 4 away. What do you mean above it? 4.46 is below. That's why it's negative. Less than I don't. So, does that help?
Oh, okay, yeah.
Oh, shit, so, do you want us to put the
You don't have to, as long as you do it correctly. I kind of do, just to remind myself what the hell I'm doing.
It's on the test out.
I put it because it helps me, but if you can do it without it, it's fine.
I mean, that's kind of my last attempt. I just didn't count. The data you can count when you number of tickets over 30.
Yeah, all right. All right.
Okay.
But you're kind of defining the screen. You're not saying, you're not
I mean, you're
referencing the problem.
I said
You see what I'm saying?
Yeah, you're counting the membership count. So you're counting the number of people.
There you go. Number of people. Yeah, anyway, let's try that. Okay. Stick.
All right. That's a way too.
Uh-huh. No, that's got to have a power meter. Maybe. I know there's a scientific calculator that's got that. I don't know if there's a TI.
Oh, do you have any extra empty pads? Yeah. Thank you.
Sure.
We're making test corrections. We just kind of